The subject is coding theory and applications, pre-elective for fourth year first semester students. Prerequisites for this course is mathematics and digital communications. Upon completion of the course, the student should be able to apply information theory concepts to evaluate communication system performance, analyze linear block and cyclic codes for error detection and correction. Third one is third course outcome is implement convolutional coding and decoding techniques for reliable communication. Fourth one is explain burst and BCH coding technique for error detection and correction. These are the four Bloom's levels: apply, analyze, apply, and analyze. Unit 1 for this course is coding for reliable digital transmission and storage and linear block codes. These are the contents which are introduced in the first unit. Importance of that first unit is this unit forms the foundation of coding theory. It explains how information is measured and transmitted efficiently through communication channel. Students learn the concept of entropy and mutual information, which are essential for understanding data compression and channel capacity. Measure of information. Measure of information is denoted by I is equal to log 1 by P to the base 2, where P is called as the probability of occurrence of an event. That is called as measure of information. Students learn the concept of entropy. Entropy means uncertainty, and mutual information. Mutual information means the amount of information is measured, transferred between output and input. From input to output is called as mutual information. Next one is the linear block codes. In Hamming codes introduces the basic techniques used to detect and correct errors during the data transmission and storage. With the help of mathematical model and matrices, detect the transmission errors present in the transmitted data and correct the transmission errors at the receiver side. Applications, block code applications. Computer memory system, it is used in computer memory system, hard disk and SSD, CDs and DVDs, digital communication system, satellite communications, and mobile networks. Coming to unit 2, cyclic codes. Description generator, description of the cyclic codes, polynomial representation, algebraic structure, which are used in the cyclic codes. In case of linear block codes, which uses the matrix description, here generator and parity check matrix, encoding, syndrome, computation and error detection, decoding, cyclic hammering code, short and cyclic codes, error trapping, decoding for cyclic codes, majority logic decoding for cyclic codes. In unit 1, block code is represented by N, K. Cyclic code is the subclass of linear block code. It is also represented by N, K. In both the cases, we use syndrome computations for error detection. Number of parity bits in both the cases is equal to N, R is equal to N minus K. Importance of that cyclic code is cyclic codes are widely used because of their simple hardware implementation. In case of block codes, matrices are used to analyze the performance. Matrix, generator matrix, parity check matrix, etc. As your N value increases, complexity is more in block codes. In case of cyclic codes, N value increases with the help of polynomial representation algebraic structure. Hardwares are implemented very easily compared to block codes. Cyclic codes are widely used because of their simple hardware implementation. Their algebraic structure allows efficient encoding and decoding using shift registers. This unit helps students understand polynomial representation and practical coding techniques used in modern communication system. Applications. It is used in QR codes, barcodes, Ethernet communication, USB communication, digital television, storage devices. Coming to third unit, convolution codes. Encoding of convolution code, structural and distance property, maximum likelihood decoding, sequential decoding, majority logic decoding of convolution codes, application of Viterbi decoding and sequential decoding, application of convolution codes in ARQ systems. Graphical representation and mathematical representation of designing of that convolution codes are very, very important. Next importance of this course, this unit is convolution codes are powerful error correcting codes used in noisy communication channels. The Viterbi algorithm, one of the most important decoding method, enables reliable data transmission. Viterbi algorithm is the playing important role. Tree and try list diagram helps visualize the encoding and decoding process. Applications, wireless communications, deep space communication, satellite system, 4G and 5G networks, GPS systems, automatic repeat request systems. Fourth unit is burst error correcting codes. Decoding of single burst errors correcting cycling codes, single burst error correcting cyclic codes, burst error correcting convolution codes, bounds on burst error correcting capability, interleaved cyclic and convolution codes. These are the topics to be discussed. Single error means only one bit is corrupted. Burst error means consecutive more than 2 bits are consecutively corrected. That is called as burst error. Importance. In practical communication systems, errors often occurs in groups called burst errors rather than a single bit errors. This unit teaches techniques to detect and correct such errors, burst errors. Interleaving techniques improves the reliability of communication system by spreading burst errors into smaller errors that are easily to correct. Applications. Magnetic storage systems, optical communications, wireless channels, digital television broadcasting, data storage devices, internet communications. Coming to fifth unit, BCH codes. BH codes definition, minimum distance and BCH bounds, decoding procedure for BCH codes, syndrome computation and iterative algorithms, iterative algorithms. Importance. BCH codes are advanced cycle codes capable of correcting multiple errors. They provide higher reliability than simple block codes and are extensively used in modern communication and storage systems. Students learn algebraic decoding methods and polynomial techniques that are essential for advanced error control coding. Applications, NAND flash memories, SSDs, QR code satellite communication, high-speed data communication, optical storage systems. The overall importance of this course, after completing this course, students will be able to measure up information and analyze communication channels, detect and correct transmission errors, design linear block codes and cyclic codes, construct tree and try list diagram for convolution codes, understand burst error correction techniques, design BCH turbo and space-time codes, apply coding techniques in storage, wireless and satellite communication systems, develop reliable digital communication systems. This course is highly important for careers in embedded systems, VLS design, wireless communication, satellite communication, networking, IoT systems, data storage technology, 5G and future communication system, research in communication, engineering and signal processing. Textbooks. These are the textbooks, 2 textbooks. Reference books are also 2. This is the total course